Hey everyone, here's our math problem for today. Let's say we are given these two congruent circles that are tangent externally. The radius of each of these two congruent circles is 10 meters, and we draw this horizontal line. At this space, let's insert a square with a side length of x units, and we would like to find what is the area of this red square. You can pause the video and see if you can solve this interesting geometry problem. Now let's solve this problem together. Let's begin by doing some construction. Let's call the first circle as circle O, and let's call the point of tangency of these two circles as point P. Then the point of tangency between the circle and this red square is point Q, and let's connect the center O with the point of tangency Q. Here, OQ is another radius, therefore its length is also 10 meters. Then from the center O, let's drop a perpendicular line segment. Let's call this as line segment OR. So we have here a 90-degree angle and another 90-degree angle here. Let's call this point of tangency of the second circle and the horizontal line as point T. Then from point Q, let's draw another line segment that is parallel to RT and perpendicular to line segment OR at point S. Now, since the height of our red square is x here, it follows that SR has also a length of x units because we have here a rectangle where opposite sides are equal. Then, since the radius OR is 10 meters and SR, which is part of that radius, has a length of x units, then the length of OS must be 10 minus x. Then finally, let's call the length of SQ as y units, and let's concentrate on this yellow right triangle. From the Pythagorean theorem, we can form this equation. The square of 10 minus x plus the square of y is equal to the square of the hypotenuse with a length of 10 meters. Expand this square of binomial as 10 squared or 100 minus twice the product of 10 and x, so we have minus 20x, plus the square of x. Copy all the rest. Subtract 100 from both sides and solve this equation for y squared to arrive at y squared equals 20x minus x squared. Then let's take the square root of both sides to find the value of y. Since y is the length of this side, y must be positive, so we just take the principal square root of 20x minus x squared. Let's keep this result for a moment. We are going to use this later on. Next is, let's go back to our figure. Since we have here a square, if one of the lengths is x, all the lengths of this square must also be x units. Then let's connect point P with the center of the second circle. The radius must also be 10 meters. Then from the center of the second circle, let's connect that point to point T. Then from this point of tangency, let's also draw a mirror image of what we have here at the left side, and here is the result. Line segment also, which is perpendicular to this vertical line segment. If this is y, this also has a length of y units. So we have here a perfect symmetry. Notice that we have here a rectangle, and the opposite sides of a rectangle are equal. So, if you add y plus this side with the length of x plus this side with the length of y, the sum of these three measures is equal to the sum of these 10 meters and 10 meters because opposite sides are equal. And therefore, we can now form this equation. X plus 2y is equal to 20. But what is the value of y? We know that y is equal to the square root of 20x minus x squared. So let's do the substitution. Then let's subtract x from both sides, and let's simplify this further. To eliminate this radical symbol, let's square both sides of the equation. The square of 2 is 4, and the square of the square root of 20x minus x squared is 20x minus x squared, and we copy the right side. Then simplifying further, distribute 4 to 20x minus x squared to get 80x minus 4x squared, and expand the square of 20 minus x to arrive at the square of 20, which is 400, minus twice the product of the first and the second terms, plus the square of the last term. Then let's gather and combine like terms. So we add 4x squared to both sides to arrive at 5x squared at the right. We subtract 80x from both sides of the equation to arrive at minus 120x at the right, and we copy 400. Nothing is left at the left side. Then let's rearrange the terms. There is a common factor of 5, so let's divide each of the terms by 5 to arrive at x squared minus 24x plus 80 equals 0. And this is a quadratic equation that can be solved using factoring. So using the tic-tac-toe method, the factors of x squared are x times x. The factors of 80 that when added will result to negative 24 are negative 20 and negative 4. Notice that if you multiply x times negative 4, we get negative 4x, and this x times negative 20 to get negative 20x. When added, the result is negative 24x, which is the middle term. So the factors of x squared minus 24x plus 80 are the quantity x minus 20 and the quantity x minus 40. We copy equals 0. Then using the zero product property, x minus 20 is 0 and x minus 4 is also equal to 0. Which means that x is equal to 20 and x equals negative 4. Notice that the radius OR is 10 meters and x is just a subset of OR. Therefore, x cannot be more than 10, and so x equals 20 is an extraneous root. We only accept x equals 4. So when x is equal to 4, substituting now that value for x for the equation that we set aside, we now have y is equal to the square root of 20 times 4 minus the square of 4, which is equal to the square root of 64, or y is equal to positive 8. So we now have the values for x and y. And we can now find the area of this red square by just squaring this x. But let's check if this really is the correct values for x and y. Let's go back to the Pythagorean formula and let's substitute 4 for x and 8 for y. And simplifying, we have 6 squared plus 8 squared equals 100, which is equal to 36 plus 64, which is indeed equal to 100. So it's verified that x equals 4 and y equals 8 are correct values for this geometric figure. And so for our final answer, the area therefore is equal to x squared, which is equal to 4 squared, which is equal to 16 square units. And this is now our final answer. Thank you very much, and we hope to see you again on our next video. Bye for now.